This is a lecture on 8-2, the use of a calculator. So I'm looking back at example of the medical doctors, and what we're doing, this example used the traditional method, but what I wanted to show you is how the z-test statistic just pops out of your calculator, and then you can decide whether you want to use a traditional method versus a p-value method. Under stats, go over to test, and the z-test is your first test. Data is used in examples where there is a list of numbers that's given to you. All it's going to ask for is where is your list, and where is your what is your null hypothesis, and what is the standard deviation of a population that is given to you. In example that has to do with the mean age of doctors, I was given the stats. The mu sub 0, that's the null hypothesis. So we're going to type in 46. The standard deviation of a population should be given to you within the problem. In this case, it's 4.2. The x bar is the sample, the average of the sample, which is 48.6. And n is the number of people that were surveyed. In this problem, it was 30. Then you have to make a decision on the alternative hypothesis. If the alternative hypothesis says mu is greater than 46, you will choose mu is, and then go over to greater than mu sub 0, which is inputted at the very beginning of the screen. Go down to calculate. The first thing that is going to spit out is the z, that's 3.39 that I just wrote down on the previous video. When writing this down on the test or on the homework, I'm interested in the z-test, all of the statistics that you put into your calculator, the null and the alternative hypothesis, the z-test statistic. If you're using a p-value, then the p-value, and if you're using a traditional method, the critical value. Notice, this is a very big mistake in this section. A p-value is the size of your tail. It is usually a very small number, certainly less than 1, because the whole distribution adds up to a 1. So what you will see very often is this e-4. This refers to the scientific notation. That means that your p-value is actually 3.5 times 10 to the power of -4. So it's 1, 2, 3, 4 decimal places to the left, and it's a very, very small number. If anything, I can tell by the size of this p, irrelevant of the alpha that is given to me within the problem, it's going to be less than alpha, meaning reject the null hypothesis. If you'd like, you can use the z-test statistic compared to the critical value. If you'd like, you can jump into the p-value method as soon as problem number 1. Let's do the next problem. I'm going to quit out of this menu, go into statistic, and choose the z-test again. It does save your previous results. There's no need to clear them unless you really, really need to. My second example has to do with the wind. So I again use statistics. The null hypothesis is given to you at 8. The standard deviation of the population was at 0.6. The x bar given to you was 8.2. The n is 32. We are running a two-tailed test, so I need to say mu is not equal to mu sub 0 and calculate. If you want, you can actually draw this out. It will draw out the size of the p. the p-value. So then you can compare it to the alpha that's given. And then you can calculate. And then you'll notice your z-test statistic is the second thing. This is the actual formula of the z-test. This is a must-have information. And the p-value is the next one. This one doesn't have any scientific notation because it's 0.059, so just a little over 5%. Now, because my alpha was at 5%, this happened to be greater. If my alpha was at 1%, this would be less. So depending on your alpha, you can actually bend and squeeze your numbers just a bit so that you either reject or do not reject the null hypothesis if you are in the border cases. For all of the problems in the book, the alpha will always be given to you, so you do not need to guess this one out. The only time that you are asked to guess and kind of play around with this is during the project, and if you have any questions, please let me know. If you are running, so when you're doing some homework problems and you're running a test that requires data, all we're interested in is input all of your data in L1. Make sure not to make any typos. The rest is pretty self-explanatory. You will put the number for your null hypothesis. You will put the number for your standard deviation of a population that is given to you, and choose, you tell your calculator whether it's a two-tailed test, left tail test, or right tail test.